Hey guys, welcome to the second video in class 11. In that previous video we kind of introduced you to sedimentary rocks and some of the different environments they form in. In this video I want to dig a little deeper and look at sedimentary structures and how we might make observations of sedimentary rocks that could further help us figure out what environment they formed in, and then also how we can kind of read how those environments are changing over time. So again, this is important because sedimentary rocks and sedimentary structures help us determine how that environment's changing over time, which is really the basis of reconstructing what's been going on Earth for the last 1 billion years. So quite a long record. So in this video, I'll introduce you to cross-bedding, then we'll talk about ripples, burrows, and rip-up clasts, and then we'll talk about sedimentary beds and stratigraphy. I'll just say a lot of what we're going to talk about here is geared towards preparing you for our lab the week before spring break, when we'll be seeing examples of all these things in the field. So I've picked these things because you're going to be seeing them multiple times in the weeks to come. So what is cross-bedding? So cross-beds are a type of sedimentary structure that are created by the movement of sand dunes or ripples. And the way that sand dunes move is that grains of sand bounce along the back of the dune, and then suddenly enough sand builds up here that you get a cascade of sand down the front. And that's literally how a sand dune migrates. Sand comes up the back and falls down the front. And actually, before we go any further, take a minute and watch this video. I can't show it to you here because of copyright issues, but you can follow this link, or you can just search dune migration on YouTube, and it's the video that's 2 minutes and 11 seconds long. You can probably just watch the second half of it, and you'll see an example of how these ripples or sand dunes move, and that's going to help everything else will make more sense after you watch that video. Okay, so hopefully you've watched the video now. You have an idea of how these ripples and dunes migrate. And so cross beds are literally the beds that are left behind each time the sand topples down the front. And so we end up with these kind of tilted linear beds that each record a single avalanche of sand down the front of the moving dune. And these are also sometimes called foresets. And it's very important to note that these only really form when dunes are migrating in a unidirectional direction. So when they're moving in one direction under a current that is flowing also in that same direction. So here's an example of what foresets look like. These are very large foresets deposited by migration of a huge sand dune, bigger than a house or something like that, across an ancient desert. These are from the Navajo sandstone in Zion National Park. So these are recording an ancient sand dune. Here's a person for scale. And each of these beds represents a cascade of sand down the front of that migrating dune. Of course, we also see cross-bedding at a much smaller scale as well. Now, lots of other types of cross-bedding exist, and I want to focus on one in particular. It's called hummocky cross-bedding. And this is basically very shallowly dipping beds that tend to drape on top of one another. So they have that cross-bedding effect, but they're much less steep, and you tend to see them occurring in both directions, kind of off to the right in some places, and then also off to the left in other places. So they're lower angle, and they dip in both directions. And those are called hummocky crossbeds. And these are formed by oscillations of wave currents at depth, where waves are pushing both forward and backwards in a relatively gentle motion, moving the sand back and forth and forming these lower angle beds. And generally they're formed by currents or wave energy that's much subdued compared to regular cross bedding. And so importantly, these form just above the wave base. So whereas cross bedding might form in really shallow water, this hummocky cross bedding forms much deeper water and is usually can be interpreted as being near wave base or just above it. Okay, so now let's move on to other structures: ripples, burrows, and rip-up clasts. So burrows are often preserved in sandstones or dolomite, and they're left behind by sand creatures that are literally crawling around through the sand and eating. So here's some example of some crabs that are burrowing into a sandy beach at night. Here's some other burrow holes where crabs or other creatures have gone in and out of the sand. And they crawl around under there and they basically leave a track. And so when we look at modern limestones or dolostones, sometimes sandstones, we'll actually see these tracks recorded as fossil tracks going in and out of this rock. And so whenever you see burrows in a rock, that's a sure sign that you were probably in the tidal zone, relatively shallow water where the high tide was covering it and the low tide was exposing it, leaving lots of yummy food for these creatures to eat as they crawl around. So burrows are pretty much a sign of you're somewhere in the tidal zone, which means you're in relatively shallow water. So another sign that you're in the tidal zone is ripples. And especially if they're very small scale ripples that have a low amplitude and a low wavelength, these are often formed by tidal currents coming in or going back out in relatively shallow water. And these ripples can actually be preserved in sedimentary rocks and are often a sign that you're in a tidal flat environment or quite shallow water. Another thing we'll probably see in the field are rip-up clasts. And so these are created when there's a pretty abrupt, strong storm event or a flood, some really abrupt, strong current or strong flow that comes along and rips up partially cemented sediments and then churns them around and deposits them in a kind of chaotic way in a generally a poorly sorted deposit. So what we're seeing here is some probably shallow water beach deposits, sand or dolostone here. And you can see in some places the bedding is fairly regular, maybe created by wave action. But then in some other places, maybe in here or up in here, we see what appear to be beds that are broken and kind of tilted at all funny angles. And those are rip-up clasts. Those are examples of where a high energy event came in, destroyed the bed that had partially formed below, and deposited chunks of that bed in a maelstrom above it. So those are called rip-up clasts. They're created by strong currents. And of course, usually you need to be in fairly shallow water if you're going to have currents that are strong enough to create rip-up clasts. Okay, for the final section of this class, we'll talk about sedimentary beds and stratigraphy. And sedimentary beds are one of the hallmarks of identifying sedimentary rocks in the field. And here's an example, some limestone beds. And the bed unit is a given little block right here. It's tabular, usually has kind of some weathering or open space at the top and also at the bottom. So it's kind of separated from the beds above it and below it by what look to be fractures, but they're not really fractures. We'd call them contacts, where you actually can have a little bit of open space. And usually what these contacts reflect is some change in the sedimentation style. Something changed. Maybe it was the water depth, or maybe this whole bed was deposited in a single storm event, and then there was a period of calm afterwards. But they kind of reflect periods of time when conditions were perhaps roughly consistent, then something changes and we get a new bed deposited above at a later time. Now, sedimentary beds make great markers because they're almost always deposited horizontally, at least in the ocean, and they can be continuous laterally. So they can be a great way to know which way was up and see if any tilting has occurred. So those are sedimentary beds. Now, if we read a lot of information from sedimentary beds on the large scale, then that's called stratigraphy. Stratigraphy is what you get when you have a lot of thick sedimentary beds deposited on top of each other, and you can break out those different sedimentary units into units which share similar properties, and you can infer the conditions under which each of those units was deposited, and then really think about how things were changing through time. So in this example from the Canyonlands, obviously the older rocks are on the bottom, younger rocks are on the top, and these changes in sedimentary environment are consistent across wide areas. Wherever you go in Canyonlands, you'll encounter these same rock units which record the same changes in Earth's surface condition. And so it's by looking at how the stratigraphic conditions are changing that we can really build up a record of Earth history. However, that record isn't always continuous. We know that sedimentary units are accumulating over time, so they're a record of time, but there's also gaps, and we call these gaps disconformities. So these are places where one unit is usually truncated and another unit is deposited right on top of it. And there's some missing time right here. This is a period of time when either sedimentary rocks weren't being deposited, or if they were being deposited, maybe there was a period where there was an erosional event that actually removed part of the stuff that had originally been deposited and then put down new material on top of it. So disconformities represent gaps in the sedimentary record, and sometimes they're associated with erosion, sometimes deep erosion of the underlying sedimentary unit. So it's important to recognize that although sedimentary rocks are a record of time, they're not necessarily a continuous record of time. Some units can be deposited very quickly, and then there can be pauses, like disconformities, where nothing is deposited. So they're a good record, but they're not a perfect record. So in summary, we've covered cross-bedding, ripples, burrows, and rip-up clasts. We looked at sedimentary beds, and then talked a little about how we can interpret stratigraphy on the long scale. I actually skipped strike and dip. I think we'll talk about that at a different time, maybe in the field. So here's a couple concept questions and a link to the quiz. And I'll see you maybe in a week or two whenever we resume these videos. Thanks a lot. Bye.